Hello! So I would like to present a little bit of this setup because I find it somehow interesting. It is a setup of like straw interacting with some character walking into it. As you can see, there is some height to the straw. And I don't know, I turned out to be a bit happy with the result of it, and it has some interesting technical approaches. And so I think, yeah, it could be interesting to show a bit. Just to give a fast sneak peek of it, it's like at first I started with a vellum approach, but it turned out to be a bit difficult to stabilize and stuff. And at some point I thought maybe RBD would be better for that. And actually, yes, it's an RBD setup, and it makes it a lot more controllable and stuff, and also faster to simulate. So yeah, that's the sneak peek, and let's dive into it. So at the object level, simple like just setting my camera to make always the same visuals of it, some light for better visualization, and a render node and some material in which I just assign a dark material on the ground to really see the stroke pretty clearly. That is pretty straightforward. And then for the stroke setup, that's how it looks like from the further side. The straw being set on this part, the left here, and then here is the part where I decided to. At first, I did build it with the crag, and it has some good things in crag animation because you know he has a hammer and he's working very slowly, and he's really like doing different movements. So it was actually a good case to develop the setup, but I thought it would be maybe a bit not enough. And so maybe like in my case, the case I had was with an animal with 4 feet. And so yeah, probably having a horse walking through it, walking, trotting, running through it would probably. I wanted to test it with different animations just to see how solid it is. So we'll see. Another thing that I would like to say is that in this video I think I will like go through each node trying to explain it. The goal being that you would be able to rebuild the main of this setup yourself or take the aspects that you like of it, and then if you wanted to have the file like to download the setup and not go through the steps of rebuilding things. I'm thinking of making a version available on Gumroad that you would buy like for a little amount, just as a reward for my little work on that, and yeah, the option will be available. Another thing I would like to say is just giving the reference for the animation download. It's like free models, free animated models. The animation is pretty cool. It just needs to restore the move or like the translation in Z because it's running on static, but I'm doing that in the setup. And I won't like include the animations in the Gumroad download because I find it's better if you just download it from the Sketchfab itself so that the guy gets his statistics accordingly. And so I will include just the links to the animation. It's the same guy that did the walk, the trot, and the running horse, so that made my happiness. And I found another one that I wanted to try at first, but I didn't in the end. But it's a little running rat, which is probably a lot more small scale, so I'm wondering what it would give with the setup. It would have been fun to test, I guess. So I will give all the links, and you guys are free to download it and play with it. Okay, let's start with some notes that I'm leaving at the beginning. It's like, yeah, it can depend, of course, on the machine and the resources that you have to be able to run the setup. In my case, I have like 128 gigs of RAM and this CPU. So if you have less RAM, unfortunately, it could be a bit difficult to run it with the patch that I have. Like if you reduce the amount of throw and the zone and the height also, it will be easier for you to simulate. But that's what I have, and you might like it's good to know for you. Also, yeah, I do have the habit of setting my variables as being like flipbooks and cache. And that's what I set in the file path, so you will probably have to reset that for yourself on your machine. And then, yeah, I did make the little just mistake of starting my frame range at frame 1. It would have been easier to start it like at 1001. Just for the pre-roll sake, because we need a bit of pre-roll for the straw to settle. So I just made with that, but I would maybe recommend to set that to 1001 and not make the same silly mistake as I did. So that's it for the little notes over here. I will also tell a little word about limitation of the setup. There is, to me, one main limitation, which is essentially about like the deactivation of the straw. It's like, unfortunately, once it is made inactive, if there was another character, let's say, that would go through the same straw, it would need more work to be able to reactivate that part. It could be probably done based on distance from character, but there is a little chance from the tests I've been doing for that being reactivated, it would start to move again a bit weirdly, like falling. So I would recommend to reactivate it only if it's really moved by the second character again, so that the movement that would enter again in the sim wouldn't be too noticeable. Maybe I'm not sure actually how to address that issue. So if that's the case that you are meeting, it can be, yeah, can be a bit more work for that part. Another thing that I will say directly is the sim time. Maybe for those patches that you've been seeing in the demo, each patch is taking around like 3 hours to sim. It has been lower, it has been faster. Some things can decrease that time, but yeah, that's what I have for now. So let's start with the building of the straw, because we need straw, right? So just a grid, I will need the ground height a bit later to set the ground planes, stuff like that. And then I'm building a mask for the straw to be less high on the borders of the stack. So if I just dive in, up, grouping unshared edges. This node is super nice, like it's from the labs, but it's like to extract the line from an edge group. I really like it. Setting rest. I can't remember why I'm setting rest, but probably useful. Just noising the stuff and then doing some distance calculation. So the usual XYZ dist to generate the distance of the edges, yeah, of course. And then, that's it. That's why I was storing rest, just to be able to reflatten the stuff after noising the thing. And then blurring. So to blur, this is an interesting thing. Maybe I will just stay in there so that you see the result of this one. In my case, no result. So it's like, oh, I have the control exposed. So I can like, I don't know, maybe go a bit, yeah, a bit less heavy on that one. So as you can see, it's like blurring, and it's a simple trick. It's doing pretty much the same as this, but this has some issues that on the farm you might have a lack of GPU and stuff, because this one is using GPU. It would be the same of doing this. So we can use PCOpen function to like blur the position and then get the dist from it. Okay, and then a mountain, and then I'm like scattering some points on this plane. I'm blurring them with the same trick just to get them a bit closer to each other, and then it just it's like straw has a bit of that spherical stack behavior or look from what I found, so I wanted to rebuild that a little bit, have some spots. So that's what I did. I'm setting the normal because that is used by the poly extrude. Why is it used? Oh yeah, I guess it's to avoid having the extrusion on the borders. Oh, that is for it. What does it do? Yeah, okay. Yeah, that's it. That's it. Okay. And then generating some points inside the volume. And then what do I do? Oh yeah, this starts to be a bit of a something set up for the sim already. So here I'm like I did mess my thing up, right? Okay. So this is taking the trajectory of the current animation selected, which is this one. Little crack. Oh, you're upside down. Okay. So, and this is like just to generate some attributes to separate what will be sim, which is this part, what will be inside the sim but set as inactive, so active 0, just to help blending, and this will not like enter into the sim at all. And this, like the border, just helps the active sim to collide with the non-active sim, and then those blend perfectly together because this one is static. So I'm generating some attribute for that. Oh yeah, one trick that I like to do is using this expression. So I always let my visualizers inside the setup because I always wanted to visualize the same things on the same nodes. So at some point I think I'm gaining a bit of time just leaving the color nodes active there. So one easy way is just setting this expression, and then when you set the name of the color node, it will remove the number and keep dist, and so it's like visualizing dist. That's very fast, and I even have made myself a little HTA where I just do this, and then I do this, and then boom, it's done. I like it that way for now. Okay, and then so that's what we're doing. So randomizing n, removing the normal up somehow. Randomize p-scale, randomize width, randomize value, which will be used to generate a color ramp, strawy color ramp. And then I'm bringing back those up. I guess this value is probably based on, I don't know, maybe not. Okay. But yeah, okay. Just bringing them up. And then we will need a straw ID, which is like a unique ID attribute for each strand that will be copied on our lines, some straight lines. And then we resample a bit, not too much at this point, just a bit, to have some points over there. I could also have set, no I couldn't because I'm generating a NAND point group because I will want to exclude that at some point from another group, so I need that information. So resampling gently, and then getting back that end group that I will need. Group transfer is pretty cool for that. And then I have some straw underground again after that, because they are like rotated. So I remove them again. So yeah, generating a class attribute on primitive for each strand. Promoting this. This will be, I think, to be able to make noises like offsets noises on each strand. It gives a bit of a more natural look. And then corners group. I just group everything because basically concept of the setup will be that those points, basically I see strand as being like straight lines that can bend in some pretty corner, in some corners points. So I will want to build different constraints types between the points that will be here on a straight portion of the strand and the ones that will be on the corner here, because this would be able to bend, and then when I will have points over there on the body, those will not be able to bend. So I will need those groups to be able to build that kind of constraints. And here we are with a little strand stack. Not the more beautiful, not the more ugly, but something workable. On that stack we have some attributes. We have straw ID, which is a unique attribute per strand. We also have this one, which is actually pretty similar. I'm not even sure I really need to keep it so much. And we have split that would help us to split the simmed and the non-simmed strands. Okay, so now we are going to use the things that are really important for the sim, so prepping basically the strand for the sim. So I will start to use my split attribute here. As I told before, all this strand doesn't interact at all with the character because it's not on its trajectory, so I can really isolate it. I'm keeping it completely static, but something that could be done to improve the straw stack overall is like some strands are flying because I'm just scattering lines on points. But we could make a separate sim to just settle them, give them a little bit of gravity. They would like fall and just fall on each other, and that would make a more realistic straw stack. And so that could be done. It would need like maybe 30 frames of sim to get that. So would be okay, I think. We could also like maybe split it into different clusters if that amount of straw is too much to sim in just one sim. Yeah, probably that's something that could happen. And then we are going to sim only dispatch, which is really on the area of interaction. So I'm keeping this one later. So first thing we want to do is remove the interpenetrations with the character at the beginning of the animation. So here's my little crag at frame 1. And I'm promoting class again to primitive for some reason, probably for this. So yeah, promoting, and then I'm sampling the character. Let me revisualize this. Promoting, sampling, sorry, the SDF of the characters, so the values inside of the SDF are going to be negative. So I'm detecting them. Maybe 0 is not a good... I would rather do this because with just a 0 value it can get a little bit buggy. And then I'm setting an attribute for those points that are inside the SDF because I don't want to blast them directly. That would make some strands having some holes in them. What I really want is actually promoting that attribute to the full strand. If I use my little utility, set it to inside, I guess it's gonna be on primitive. So here, now you see only some points get that value being inside. But what I do want is to have the full. Of course, I have to remove CD on the points to be able to see it, and so it's promoting to the full strand. And then now I can blast it. Some can seem to have intersection, but I trust the SDF sampling in there. They might be just away, like just outside of it, maybe 0.0001, but so it should be okay for the sim. And then I'm setting this little polypath. This is basically if like it's the opposite of the convert line one. See, it's like here now I have like 3 primitives per strand, and if I want to redo that being just one, polypath can help me. It has no utility in my case, but if you were to rebuild the setup and you're doing another manipulation on your straw and stuff, and at some point you're putting a convert line, then I'm making sure that you have just one primitive, because that's important for the rest of the setup later on, if I remember correctly. So seems useful, but I leave it there for security. Okay, now, so this is really the work that is needed for us to simulate RBD of those little charming strands. So one thing that I was telling you before is that I would use, those points as being the bendable corners of my straw. But I also need points to be able to define those portions as being like straight, not bending, and to have some collisions on those straight portions also. So now I'm creating those points. It increases quite a lot the amount of points. The fuse here, I can't really remember why I did put it. Maybe it could be removed. Doesn't matter so much, probably. And then I'm getting back my corners group that I just had on my initial points, because I need it. Now I'm creating like a unique, it's like an ID. Usually we actually call it ID. I don't know why I just called it like this, but it's creating a unique point number, point attribute per point. Always useful to have that, especially like right now, to be able to set up a unique name per point, because each point will, you will see later, become an RBD like object, and so it requires a unique name per point. So I'm just using straw, doing a string, converting integer to string. I'm using, so this is the unique attribute per strand, and then underscore, and then adding the point number of each strand, which this gives me the little main attribute here, which is unique, as you can see. Tuk 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 tuk. Okay. All right. So this is needed. This is why? For some reason. So generating tangent normals. We'll see later. I don't remember honestly why that's important. And then, so now I'm converting to different primitives per point. This is important for the creation of the constraints later. It has a lot of influence on the constraints nodes later. And then, so I was keeping the endpoints group. So this point and this point were grouped in endpoints, if you remember. over there, which I've been like careful to maintain, because now it allows me to like remove it from the corner. I don't want those points to bend later, so I just remove it by using subtraction of the corners group of n groups from the corner groups. Right, and then now, so that group of a corner points really defines how rigid will be the straw. If I use it as is, it will, like, the straw will really bend in all the corners, and we will see it will have that behavior. In my case, I don't want it to be on all the corners. Straw is a bit random on that aspect, so I'm removing some corner points from the group to have some bending, but a lot of rigid also. That's how I liked it. I did some other tests of sim with more points, and it's really about the look. Like, if you want something a bit more thick and a bit more rigid, then you reduce the amount of corner points. If you want something a bit more bending, like a thinner straw or things like that, then you can increase the amount of corners. And yeah, it's just a matter of the look you're looking for. So here I can visualize a little bit the amount, and we can see there is a lot more before. And here I'm visualizing just my unique Stropity ID. Okay, now we're really diving into the RBD stuff now. Okay, going for the RBD. So we are going to make two sims. One will be the Settle Sim, which is really to just give some gravity to that straw, because you can see there is some very happy Strand that is flying and living its best life. So we want to make that better. So we're gonna have a Settle Sim just for the straw to lay on the ground, and we're gonna have an interaction sim after that, being the interaction with the character. We are going to sim spheres. Spheres are pretty good objects for the RBD to sim. It gives a good reaction overall, and it's like a little technique. It's also useful, for example, for some colliders for RBD, like organic colliders. I will show a bit later, because that's what I'm using. I'm using an RBD sphere collider, not for the crag, but for the horse. That's what I'm using, so I will show a bit of that later. And yeah, spheres are really faster to simulate for the RBD, so it's a good thing. So we are going to copy some spheres on our strand. I'm decreasing a little bit their P scale, because I think it helps them to settle a bit. I want them to be able to just go slightly interleaving, like we would have some spheres being able to go inside that way. They would collide with those two, but they would like interleave, and I think it helps them to settle a little bit and not slide too much over each other. So yeah, I'm decreasing P scale for that mainly, and then packing. Here I'm losing the name attribute that I've been creating before, so I have to like restore it. But now we can see I have my packed spheres with all my little attributes that I like, because I did transfer them over there from points to centroids. Okay, and then yeah, little RBD attributes. The friction is going to be pretty high here, because we want like straw has quite much friction. I'm setting bounce to 0. I really don't want any bounce, and even a small value is giving me some, so really 0 for the bounce. This I'm asking myself, is it useful? And I didn't actually like, I don't know, maybe not. I just keep it there. It's not so important. And then, yeah, we are going to set the active and the animated to 0 to tell we don't have an animation to follow. It can be fully simulated. And then here, this is like to set the border. So I want the straw on the real border of the trajectory to be static. I don't want to sim that because if you remember, we have another part of the stack, which is this one, and I don't want like I want a good border between them. It's like if I went to sim that, I think we would see a difference in level, like in height, because those would fall down. And I think that would be like probably noticeable. So I'm keeping this as a blending border between my simmed area and my non-simmed area. And why is this useful to keep it? It's because I will want collisions and a little bit of connection between those two parts. So the active part would collide with the non-active part and be laid on it, to lay on it. And also have some connections with them. So that's what I'm setting here. And then I'm setting all that into my straw group. I will remove, looks like we have some issue with the viewport. It's showing me the points. Okay. It's still showing me the points. Why? Okay, what is it? Maybe the group node. Okay, so we have our spheres, proxies. We can visualize. So this is just to keep points. Deleting color to be able to visualize my attributes. Active and split. All right, we have a little proxies actually to simulate the straw. And then constraints. We are going to create really the constraint that make the straw behavior. So I told about it before, but that's now where it is really made. So I'm defining here some portions that will really be just hard constraints and won't like bend and will really be very rigid, because straw has that behavior of being very rigid, not allowing any stretch and stuff. So that's where I'm defining this. So those are gonna be I'm removing, that's where I'm using my corner groups. I'm removing the corners because I will want different type of constraints here, and that's actually the simplest way of not creating the constraints between those points, is actually just removing those points here. So I'm using a constraint property, which is going to be hard. I give it his little name to be identifiable in the sim. I'm constraining position and rotation. That's pretty much it. And hard constraints are they're very fast to simulate. So there's a big advantage of having a hard constraint like this that don't allow any stretch. It's pretty cheap. And visualizing. And then now creating the corner constraints. So those are gonna be really the ones joining here. Those will really bend. I want them to bend. So in this case, I keep only the portions that I want to be bendable. I think that I have actually some. I wouldn't want this. I'm not sure why I had that mistake in that group. Maybe because I have like this being a corner, this being a corner. That's probably it. But I mean, it's okay for the final result, so let's not worry too much about this. For this one, in this case, because we are in the Settle Sim, I'm gonna keep it as being hard and constrain position only. So in this case, rotation is free of moving a bit. So we can have a bending, which is cool. Nothing much more to say actually. Hard constraint, giving the name. That's it. And then, so for my Settle Sim, that's where I'm connecting my active straw to the inactive straw, just to not have that height level difference between the two. So as you can see, active, inactive, and then splitting the two and finding the distance between the active and the inactive, just so that just the straw really close to the inactive would generate some connections. I'm keeping, so this is the active portions, right? No, this is the inactive portion. Well, I can tell. Yeah, this is the active portion. Okay. Merging them, setting them into group to be able to generate constraints based on those groups. I'm searching in a certain radius, which is linked to yeah, this parameter. Okay, if I remove this, it's gonna be 0.1 increasing slightly, and yeah, we can see the max distance that I used was this. Okay, so generating those little constraints. The amount of constraints is the more important parameter for their stiffness. The more you have connections, the more it will like stick to it. It make it pretty strong. So in my case, I have quite many. And then setting like constraint with that to really maintain them near that inactive strand, and constraining position only. Okay. Then I merge all those constraints together. And then I'm going into my sim. This one is going to be pretty straightforward. There is not so much. It's actually really about like creating the constraints, setting based on the name that I gave them before. Creating the constraints, importing the proxy spheres from there. One parameter that is important here is probably this one. It has a big influence. It's like it's going to, if I show, it's going to extend or not the collider of the spheres. And I found that if I keep it a bit higher, it maintains more volume in the sim, of course, because all the spheres have more like are extended, so they collide faster. And if I hope it's gonna make it, because maybe it's gonna be a bit heavy for it. And if I decrease it, they will maintain less space. Up. Oh, we got lucky. So yeah. One thing that I noticed at some point is that I did sim as a convex hull. I think it is way slower than something else that I could have done, which is setting this to sphere. I did some tests with that. It was extremely fast, but I was losing a lot of my dynamics that I had like already tweaked somehow. Like what I found is that the constraint needed a lot more stiffness, not stiffness in this case, but needed like I needed to push. I think it was iteration that I had to push to like 100 to force it to really do a lot of iterations to be able to maintain that hardness. It's a bit weird. I'm not sure why switching colliders to spheres makes such a difference in the dynamics. If it was to redo, I would probably set the setup as being sphere from the beginning and tweak my dynamics with sphere from the beginning, because the performance gain was huge. It was like 10 times faster at least. So yeah, convex hull, a bit of a bad choice from me, but yeah, I'm mentioning it so that you don't, maybe you can correct that before you start working. So after that, nothing special in the RBD solver, just increasing the constraint iteration just a little bit to help them settle gently. Didn't increase the substeps, it was okay like that. I'm using a ground plane which is linked to the null just at the very beginning of the setup, which was calculating the height of the grid. If you had a ground that was not flat, you would need different collider here, but I'm using a simplest way for that, and then just the normal gravity. Okay, so from there we end up having a sim that is broken. Hopefully. Okay, I guess I broke my caches somehow. So it's a bit sad I can't show you the settled result, but basically I'm a bit annoyed with that. Maybe I can just at least show you the points. It's probably because the points count change during doing the demo or something, and then yeah, it tends to break a little bit that thing. And so what it does is, if I remove those guys, just settling the stroke. I let it live for, how much did I? 30 frames. And then it's done, and then I keep it at the last position. Yeah. So at some point I was having the little time-dependent watch here, so I really forced it to be, maybe because of the expression, so I added this one to really force it to be static, but now it seems to not be doing that anymore, so yeah, it can seem weird, but that's why it's there. Okay, and then we're nearly ready to go to the next part of the setup, which is really the interaction with the character. Alright, so about the interaction sim, we are going to start from our spheres. Oh, sorry, I skipped that part. Okay, so here what I'm doing basically is just applying, you know, that simulation, like just the last frame position of the point, and then applying that position to my spheres, to my straw stack, which is coming from here, because here I just cache points, so I don't have those spheres being at the right position. So I just reapply the position. This is on the RBD spheres, and I'm doing that also on the strand, probably. Don't remember why I used that. Yeah, to generate constraints again, based on the new position, because we need some other kind of constraints for the interaction sim. And also, like at the very end, to apply the simulation to the strand and stuff, I need a strand to be in that position. Another thing, so like, yeah, tweaking the dynamics is really about being able to have a bit of fast testing of some parameters and stuff. So what I really like to do is that most of the time I don't need to have the full straw amount during the test. So I can reduce the amount. What I have inside is just a switch with a control at another place of the graph that I will show you. And it's like I'm reducing by a different amount. Here, reducing just a little bit. That's a classic remove point based on here. It's like the unique attribute per strand, if you remember. And then reducing a bit more. and then a bit more. Maybe I should do that so that we can see more clearly, and then a bit more, and there a bit more. So that sometimes I really can't do my tests on those, on just that amount of strand. So there is that thing to be able to reduce the amount, and there is also this thing. We'll change the switch to be able to really test only on a certain zone of yeah. We don't need to sim the full patch all the time and stuff. So I'm applying that there. I'm applying that. It's linked module. It's all parameters are linked to the same thing. Because I need the points, like the point count to match between the two. So I'm a bit forced to do it twice. It's not, yeah, I don't know, it works. It's okay, I think. So that's an optimization module for sim tests. It's really something that I find useful, and once it's set, I don't touch it anymore, and it's just useful for me. And where that is linked, I keep a little null near me, because I spend most of my time probably watching this part of the graph. I just like to have everything there. I can control it there, tell it reduce more, please, reduce more, and it just does. And I don't have to go back every time looking for the parameters, changing it there. It's way faster to have it like close to me, close to the interest point of the graph, and that's a way I like to work. And then, so we are going to, I can keep that portion, it's going to be even faster. On the spheres, so yeah, I'm setting another attribute here, which is TROT B, and it's because when I blast some points here, of course the point number doesn't match anymore to the original state, so I have to create another one for the manipulations that I'm doing here. And what I'm doing here is I'm going to loop over each strand, and it's pretty simple. It's going to be a bit of a array things, and I'm just like registering yeah, the point numbers of all the points that are siblings, so that are on the same strand. So what it does, it's like this is just to define how many times I need to loop, which is equal to the amount of points, setting the array variable, and then setting the loop. So I will loop the amount of a point that I have, and then I'm getting the attribute that I was creating just before, as I told. So I'm getting that for each point. Tuk tuk tuk. It's going to take the point number, storing that into a stropity variable for the loop, and then yeah, appending the point number tuk 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 every time to that array. And then I set the attribute, the point attribute, because that will be needed in the sim, and I'm running on detail, so I need to set the point attribute. Okay, I'm doing that for all the strands. And yeah, it is faster to get that siblings attributes outside the sim, because it would be heavy to do at each frame, and it's gonna be static, like it doesn't change over time, so I don't need to regenerate it, just once is okay. And so yeah, we can see that each strand, each point has the information of its actually brothers and sisters of the same strand. That will be useful a bit later. And then, so we are recreating some constraints for the interaction sim. It is gonna be pretty similar to what we did before. So blasting the corners, the groups is still the same. Still hard constraint for those rigid parts of the strand. Actually, nothing changed so much over there. And then again for the corners, so those are iterations that I kept. We are keeping the corners. Yeah, I forgot to mention that if we didn't extend, we would just like have nothing, because we need to keep the point, but also the ones just after that. So I have two choices for the creation of the constraints. I did some tests. I did kind of like with hard constraints positions only, just as we did for the settle. That was for very rigid like straw. But I also wanted to give a test to some soft constraints for the corners. And so that allows some bending, so the stiffness, the position is going to be pretty high so that we don't have any stretch, but I allow a lot more like rotation into that, and I enable also a little bit of like plasticity, because once the straw has been bended, we don't especially want it to come back to it, or to its original position. So we just like, if it moves just a little bit angle, we are going to update the rest rotation, like the rest position from the constraints. And there is no hardening, like setting a value of a 1 is no hardening. We want it to be able to bend again if another character goes through or something. So the two are working fine. I ended up keeping the soft because it was allowing more bend, so that's a choice. And then another type of constraint that we want for this sim is gonna be the connect strand constraints. And what this is doing is just doing some little clusters of strand that would be interconnected a little bit. Because Strand really has that behavior of like all the strands, they are interleaving, they are making noddles a bit together, and so they move. When one moves, it tends to move some others that are pretty close to it, and it gives a lot more realistic result than just isolated strands which are not connected together. So here, I guess I'm keeping my only the active portion, keeping the points. Then yeah, I will want more connection near to the ground and less upper. It feels pretty instinctive, like yeah, I think it's because the straw near the ground is more packed. It's been there for longer, and there is some weight over it. So it's kind of logical to have more connection between the strand on the lower part near the ground that's on the upper part where it stays more separated. So, and then I keep just on some point of it, which will be the centroid for the clustering. So yeah, keeping some, nothing so special there. And then setting the cluster based on, I could probably do this, I hope it's on point. Look. So setting cluster with a near point calculation. So just yeah, finding the near point from those centroids, defining a maximum distance to it where it would generate connect constraints. That's pretty much it. And so we can see if I increase the distance, we can see clusters, and we can see it even better here. Can't remember which which value I did set before. Yeah. Okay. Yeah, we have some little clusters. And then I'm blasting everything that has a new cluster attribute. I did set my cluster to -1 at some point. Can't remember where I did say that. Said that somewhere. Anyway, so I'm removing everything where the cluster attribute has not been set. Oh no, it's the nearPoint function that returns -1 when it doesn't find any point. Okay, that's it. Yeah, so I'm keeping that and then creating constraint attributes on those primitive generated. I guess you could have done something with this node, but I don't know, it was easier for me to set it like that. And then I do set a group for those constraints, because later on I will want them to be able to break if they have a certain amount of force applied by the character, so I'm setting them into that group. And then two ground constraints, that's another type of constraint. Let's show the result directly. Really some constraint maintaining the strand in position near the ground. Because without this, what I found is that it tends... Sorry, I will change the display for that. It tends, like, the character can really carry out the straw very far, and the full stack would start to slide with the character, and we don't want that. We want most of it to keep to stay in place, except the one really on the trajectory of the character. So finding some distance, so ground, dividing, setting the ground group, which is useful for this node later, setting the distance attribute, always with the XYZ dist, keeping the straw near the ground only, grouping straw, merging straw and ground for this node, which creates the constraints. Again, the more connection we have, the more solid the constraint will be, and the more it will be respected, let's say. That's pretty similar to what we have seen before. And then setting them to be hard, position only, nothing so special there, but I want them to be able to break also if the strength is very strong. If I don't break them, I will have some stretching also, so just allowing them to break. And then, same as before, merging it all together as being the input for our constraints. Alright, now I think I will do another record for the sim because there is a bit of a lot to cover. Alright, so from now, the sim, like really the interaction sim. So what I like to do, also I will just quickly explain the goal of, oops, those nodes. This is linked to really the static settled straw, and it's just there because when I switch my optimization parameters, if I do it there, it will always have to, or if I do it visualizing the result of my sim, it will have to calculate the first frame of the sim. If I do it there, it is static, so I can like set my optimization parameters as I want for the test I'm about to run. It is very fast for me to visualize, so that's how I use that guy. And yeah. Then this is to check the result of my simulation as Strand, because over there I'm importing only points. And it's not very like good to visualize the dynamics and make decisions and stuff, so what I do is I remove the cache while doing the tests. Oh, now I have to do that even. Hup, hup. And this is leading to over there.
So it's showing me my sim result as strands directly, and then I can simulate, and then I will have my my stuff. So, and I don't have to run until that part of the graph to be able to visualize. I can really stay there, work there, change from one to the other, have my environment and character visualization also at the same place, not having to look for them somewhere in my graph over there and over there. So that's what I do. And I have a little box. Yeah, having just an idea of the sizes of things if you are doing operations based on distance and stuff is always good to have just a box telling you, oh, okay, 1.3 is that in my scene. Okay, I understand. So that's why I keep it there. And then for the sim, so as I was saying before, for the crag, I'm using a pretty usual way for the collider. So importing the crag, setting to rest. Do I have an issue with oh no, it's okay. Making it static, and then generating convex hulls, packing, generating name, keeping foot only, we don't need the high part of the body to interact, and then point deforming, and it follows the animation. I have an offset at the beginning of the frame range, so. But then there is the colliders for the horse, which is a bit more funny. So for this one, a way of generating convex hulls would be probably to like generate, I guess, a VDB poly being like this, a bit smaller, scattering some points. We will keep this, and then Voronoi. And then fracturing. And then I could like this would generate convex hulls. But then if I do that and I will try put it to the point deform, then it makes some weird stuff. Oh, it's because I have to pack it also. Where is it? Oh, I didn't have it in the end. No, c'est assemble pack. Okay, see, that's not a nice collider. It's not okay. So that's why I'm using another technique for that. I could have increased, I guess, increasing maybe the amount of points could do it better. Let's give it a try. Maybe I went crazy about it. I went crazy about it. Okay. Let's say 5. Come on, little thing, you can do it. Oh. Time for a tea. Okay. Well, okay. We got it, but it's still not so, not so good. And we know that spheres, RBD really likes it, so why not take advantage of it? It is very fast, it is beautiful. Okay, I did set it back. So we are going to use sphere. I'm
setting rest, I'm removing the upper part of the body. We only need, like, we wouldn't have stroke going upper than this, I guess, probably. Unless it's flying very high, but it's gonna be okay for most cases. Filling the holes, converting to VDB, and then we have this node, which is VDB to sphere. There is a little bit of setting up for that, because when you just put it default, it's not going to give you so good results. That is like for several reasons. For example, it's like not allowing a lot of spheres at the beginning. This we can keep, but then we really want to refine the result, because here, for example, you see we have a big sphere and then some smalls, but then the straw would interact with that shape, and that's not really the shape of our foot. So there is a little bit of a good parameters to find for that. What I ended up having is those parameters, not allowing a like too big spheres, because like it's causing troubles when deforming. See, it's like they are creating holes. It's not That's not ideal. So we want small spheres overall. Tuk, tuk. And we want the volume to be really filled up with spheres, so that we really maintain that border shape over there. So yeah, just a bit of evaluation. Also, I found that increasing the point count here was giving a lot better result. Let's remove it. I don't know if it's forcing the amount of points. No, it's the maximum number of interpoints. Okay, yeah, it tells increasing discount increases the chance of finding optimal sphere sizes, so I guess that's telling just increase me please, it will help you, so I just did. And then another little thing that I thought, so here we have quite a big amount of spheres. We have, it's okay, it's like 7,000. That's okay, that's totally okay for the RBD solver to manage, honestly. But there is a way to make it better. So we can like calculate the distance from the horse surface, and yeah, generating an attribute from that, and we can actually empty a little bit those areas. It doesn't need, I'm not sure if the legs, they have any holes inside. Maybe, maybe not. Not sure. But at least we're getting rid of those internal spheres, which we actually don't want, because we want surface collision and not inside collision, and that slightly decreases the amount of spheres, so it's worth it, and it's pretty easy to set. And so now with the point deform, we end up having our little collider. Tuk tuk tuk. It's not perfect. Here I have a sphere that I could actually maybe blast if I really don't like it. See, I could really blast it. It's not behaving correctly. Yeah. And then, so I'm doing that for all the animations, duplicating the graph pretty simply. Oh yeah, also I remember that removing the inside spheres kinda helped with some other bad areas, like for example, I remember some being there at some point in some places of the animation. No, it's not going to do it. Well, I had some spheres that were displaced over there, out from the belly and from the leg, so it helped a bit to remove that. One other thing that I didn't mention is for the rest frame, I don't have a rest position on my animation, but also what I tried to do was to get the more extended frame where the legs are really like extended as much as possible. That's what I did for all, like, see, it's pretty extended. Here it's pretty extended because if you choose very shrinked frames, let's say like which one would be a shrinked one? Maybe this one is pretty shrinked. Then you would generate a fewer amount of spheres over there, and then when you would apply your animation on the sphere, there would be, we can try actually, there would be spacing between the, remember, 26 between the spheres. Then when it gets extended, see, there are holes creating because we didn't fill up with enough spheres. That's what I'm saying. So we remember 26, and we want to avoid that as much as possible. So choosing the right frame is kind of important there. And then, all right, back to our sim. All right, let's dive into the interaction sim. So now I'm using Crag as a collider. There is this little control which allows to switch animation. It's gonna drive a wedge simulation so that I could like just push one button, have the 4 simulations for the 4 animation generated while working. What I often did was doing this, removing the expression to unlink it to the wedge, and then I could like switch easily to the to another animation. Sometimes what I like to do is putting an object merge near the sim, which is like linking to the null, and this just helps me visualize quickly what are gonna be my inputs for the sim. It's a bit clearer, I find. I should have done that for the straw spheres also, having an object merge over there. And for the sim, we are going to start frame 1. I did allow a little bit of pre-roll, even though we had some settle, like the settle sim. I still needed some pre-roll because some strand were asking for time to settle even more, or to settle just like they were still moving at the beginning. So I'm giving it like 45 frames of pre-roll. That's where it would have been easier for me to start at 1001, so that yeah, it's easier just for pre-roll. And then into the sim. Okay, it can seem a little bit a lot, but it's not so much. It's like creating the constraints that we did set up before, the body constraint, corner constraint. This is a switch which is linked to my switch over there, for me to be able to switch the setup between hard and soft constraints, depending on what I want, and then connect, like this is the cluster connection constraints, and this is the constraint to the ground. So that node is like bringing to the merge all constraints null. Alright, and then bringing in the spheres. As previously, I would probably have gained in performance doing spheres, but it was breaking my dynamics quite a lot, so I didn't. Collision padding here is driving also the one on the settle sim, like both are linked because we probably want them to be the same value. So that's why this one is linked. Tuk tuk tuk. And again, this parameter has a big influence on how much volume you will have after the sim. Also, how high it can reach. For example, when the horse is walking, with the parameter higher, the stroll did reach until there, more or less, of his leg, which is a bit too high, but decreasing it, it was getting there. So that has a big influence on that. Then we're gonna have the solver that is going to break the constraints for which we did set the group to break. So it was the one connecting, like the clusters ones, and the ground ones. I don't want the strand to break really itself. I think strand is pretty fibery, like, and it's not so hard to break by collision. I think it's more if you wanted to break strand, you would need to cut it or something. Depends. For the break, I'm using that break group in there, and then I'm just setting based on force applies to the constraint on primitive, detecting if it's higher to a certain threshold, and then setting the group to broken, and that will take care of breaking them. I'm using the relationship geometry. I don't remember if I did change something for that to work. Maybe, maybe not. Yep. So yeah. So that's applying directly on the constraint geometry, which are the primitives. Okay. And then importing the character. So in our case, we can see these are little horse, sphery horse. Actually, now that I'm thinking about it, it could be also better to switch to sphere. It would be way faster, I guess. Oh yeah, the character of course has attributes set to animated 1, active 0. It has some friction bounds, and it has a group also. That's important also. Yep, and then no, that's not the good one. That's the good one. Look. Okay. All right. So I'm leaving it 45 frames of pre-roll as it is set over there. And then after the 45 frames, so what happens basically during those 45 frames is just some settling. Tuk. Can show you that. Tuk, 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 tuk. We go until 45. And then at 45, I can visualize quickly environment and character. Horse starts to move. I think I have the wrong. Oh yeah, it's because I did break this. I actually don't even need to break, so it's interacting with crack right now. Before 45 it doesn't move, and then at 45 it does move. Okay. Okay. After 45 frames, no, at 45 frames, sorry, so at the end of pre-roll, I will set a new rest position on the straw that will help me later for some settle, for the settle wrangles over here. I'm setting rest 2 because there is a weird thing that I didn't know, is that when I set rest, the solver seems to be using it to set position at some point, so the straw was going back to its position suddenly, and it's really using rest. So apparently we can't use rest, it's already used by the solver, so rest 2. So I'm storing the position once the straw is settled after the short pre-roll. And then I will go to those ones. So I have some drags. Those help the straw to like just lose energy. It's the air resistance a bit. So without this, they tend to move forever in the sim and stuff. Pretty. So we do need a little bit just of a hair resistance. It's good for pop drag and pop drag spin. I do have some. And then what I like to do is, so after the pre-roll, again, just on the straw, or it would like apply to the collider also, and I don't want that. I'm going to like find the distance between the current position of my straw. I should probably get some. No, I will show that after. So get the distance between the current position of my straw, which is position of the sim, and the recorded rest. And then also calculating the distance to the character, which is linked over there. It's the geo. And then I detect if it has moved a certain amount. I mean, it's like I set some threshold over there, simply. And then if it is a bit at a certain distance from the rest position, which means basically it has moved, then I'm starting to increment an attribute based on timing, like on substeps, so that it would remain consistent, changing the substeps of the sim. So that will increment an attribute gently, and I'm also exporting the distance from the character. Though this is really a node about generating attributes that I will need later for the settling operations. And if we check, we can actually check that. I have some visualizers. I'm not sure it will work because this is showing a moved increment. So until 45, nothing happens. That's what I told it. And then once it starts moving, it detects if it has like been made a bit further from the rest position and records an attribute. And we can see that that attribute is keeping increasing over time. It is really a gradient incrementing attribute, which is never clamped. And then that attribute will be useful, those two, the dist from character, which we can see probably also. Oh no, not yet. But yeah. So those attributes will be useful. So here it's just because I noticed that I needed different parameters based on the animation, because Crag is very fast and the horse running is Crag is very slow and the horse running is way faster. So we need to be a bit more aggressive on the settling for the horse to run, and a bit more gentle, give it more time for the Crag animation. And so what this is doing, again after the pre-roll, only on the straw, it's going to do an average to promote actually the attribute on the full strand, doing an average operation. And the averaging is going to be there. I had forgotten. Okay. So again, only on the straw. So there are 3 attributes that we will want to promote to the full strand and not only to one point, because we want it to... if we have only one point that tell I'm ready to settle, it will be made inactive, but the other points of the same strand will be made active, will still be active, and that causes stretch because the solver can't solve the constraint and stuff, because one point is active and the others keep moving, maybe very far, because pushed by the characters. So we want the attributes to be the same value on all points of one strand. The 3 attributes that we want are speed, move increments, so the little attribute incrementing based on did it move or not, and the distance from character. So that's where I'm using the siblings attributes that I've been storing before, where all points know their brothers and sisters. Siblings, if you remember. That is here that it becomes handy. I'm looping on all the siblings from one strand. I'm extracting from each point its velocity, getting the speed out from it with the length, and then I'm adding, I'm doing a sum of the speed. It's basically because the average, like in math, averaging is like adding all the values that you want to average, and then dividing by the amount of values. That's the operation. So I'm just adding all the speed to that variable, which has been declared outside of the loop, so that I maintain the value when the loop is over and going to another point. I do the same for this one, for the move increment, and I do the same for the distance from character, just summing. And then, to be able to get the average, it is what I said, it's like the sum divided by the amount of elements that we want to average, which is the length of sibling, so the amount of points of one strand. I'm doing that for the 3 attributes. It's a bit repetitive actually, but I mean it's okay to do it for 3 attributes. I didn't need to set some more automation for that. And I end up with some average value for the speed for my full strand, and also for this attribute and for this attribute. That's basically what it's doing. And so if we check the result of that, we should be able to check it. So I'll set that back to 1. I was saying, like here, if we see, I think we have different values on one same strand. And now, after the promotion, we see it has been promoted to the full strand. And each strand has the same value for all its points. That's what I was after, thanks to siblings. And that's the same for speed. And that's the same for distance from character. It is also promoted. See over there, it's pretty clearly. Okay, now we have constant value over each strand. And now I can use those attributes and make several conditions for settling. So it's like I don't want it to settle directly. I want it to settle after a certain amount of time after it has been moved. So I let that attribute incrementing just rise and increment a bit gently. And once it reaches a certain level, which means times has passed, I started to consider maybe settling it. And that's why it has to be different for a crag and it has to be different for running horse, because the horse goes very fast through it. So I want to consider settling way faster, because the point won't have any interaction. After just one fraction of a second, the horse will be far away and we don't need any more interaction. With crag, it's different. It stays there a bit longer, and there is chance that it will still interact with the strand. So I'm just giving it time before considering sleeping, actually. Also, I'm considering like if the strand is not moving too much, because maybe it is like it has been moved for quite a long of time, but it has been carried away with the character for a pretty long distance and it's still moving quite a bit, and then it's pushed out of the strand, and we don't want abrupt sleeping of the strand, which would be very noticeable if it stops while it is having a big movement, or if it's still in the air or stuff. So I'm just filtering based on average speed, and also if it is far from the character, because if it's still close, maybe it is not moving a lot, maybe, but it's still close, and with crag, it still needs to interact. So that is the 3 conditions that I want to make true before considering sleeping. And then once I think the point can start to be considered for sleep, I kill the velocity to really slow it down. That's not enough to completely kill the movement, but it's like really slowing it down. I set the group to settle, and that group will drive some more aggressive drags. You can see this used here, which will also help to remove the energy from the strand, which we want to sleep. And I start to increment a sleep increment attribute. So just as the move increment attribute, it will increase. If I do this, it will gently, like, now the conditions are respected, and we start incrementing since how much time the conditions for sleeping are respected. And once it has been respected for quite a bit of time, then now I can set the strand as being inactive, and we wouldn't feel the abrupt stop of the strand. That would be a smooth stop. And I do set it's a debug attribute. It's more of a debug attribute for me to be able to say, okay, this one has gone through all that and has been really deactivated. It's not very necessary, this one, just for me to set up the thing. And that's it. Actually, it seemed like a lot. And yeah, we can see that I have different parameters for each animation. Tuk, tuk, tuk. Up. Where I'm being a bit more aggressive for the horse compared to the crag, where it's giving it more time, stuff like that. That's about tweaking and balancing. And then nothing special on the rigid body solver. Increased constraint iteration. Again, yeah, probably the spheres. Oh no, that's what their spheres would have been better, but require too much rework on the dynamics. The ground with the parameter linked, and gravity, simple gravity. Alright, and we made it. So I'm importing the points. I'm keeping only the attributes that I want. What I like sometimes to do is to use that little prepend with attributes from reference geometry, where I'm bringing in the geometry that enters the sim. I remove the attributes that I don't want to keep on that one, and then it will keep all the other attributes that I might forget. For example, I don't know, color, p-scale, width also, maybe curve view or stuff like that I want to keep. Those also are pretty important. I could have removed the animated. I will, actually. So yeah, just remove animated from there. And maybe active. Active also. Yep. I like to keep my rest. I like to keep my split. Yes, I do. Dist. Which one is it? I don't remember. Well, there is some cleaning up to do over there. Alright, setting some group. Here is when I want to check my constraints from the sim. The thing is that they are imported as static, so if I want to apply the animation to them and see how they move, I have to use a module such as this one to reapply the animation to the points. And then I'm using a wedge of the anim index to generate the caches for the 4 sims, putting that into the cache name. I always like to keep explicit as constructed. I don't know, sometimes when I set it to constructed, it flattens the $OS, and I like to do my versioning with the $OS, and so yeah, just an old way of doing. But it also doesn't really work well, the explicit mode, with this, which allows me to like merge the wedge that I want and stuff, so I had to like create some file node with some expression over there. Like to be able to read the cache, and then when I switch this, it changes both the visualization of the animation because of where this is coming. Okay, and then of course, if we have some places where we're not happy with one strand, here I did that before because at some point I had cached the horse animation and I didn't have my full frame range because it crashed overnight. So I just froze to the last sim frame that I had, and it was sufficient for the run anim. If we have for some animation a strand that is behaving weird, we can just blast it. I think it doesn't matter so much. So I'm just removing some strands post sim. But for that I will need to visualize the TROT. I guess it's changed since I said it was some strand over there that were behaving a bit bad. And then applying that sim animation because we just cached the points. I guess it will break because of the change of the... Oh, maybe it's not so much. Still a little bit. Applying that animation. Here, I'm like doing a bit more of a more high-res look. Just decreasing and randomizing the width. The width attribute is, by the way, driving this so that I visualize my lines as curves in the viewport. And yeah, if you received a strand or stroke from an environment department and stuff, you would need to rebuild the lines based on the strand that they would give you extra. That's another part of the work, of course. That is not included in here. This is to visualize like the attributes. If you want, it is useful if you want to refine those parameters. You would really be able to like take those values, set it to there, 5, and so I would see when it would reach that threshold and be able to judge which parameter to put. And this is like bringing the part of the stack that we did leave away. I'm not doing it here because it's not presenting so good. And also I did change my I changed my zone or something, I guess. But yeah. Okay. I hope that's it. Yeah, that's it. So yeah, if you want to merge the rest of the stack, and that's it. And then included or not, I will see if I leave it. Some stuff to generate the flipbooks automatically for the 4 animations. Generate a QuickTime, like a MP4, a video from it, and stuff like that. And that's pretty much it. I hope I did cover it all. And I hope you liked it. And don't hesitate to let me some comments about it. I'm like free to open discussions. Thank you.